Good evening, students. Welcome back to physics sessions. Today our topic is motion in a straight line part 2. So in today's session, we are going to learn the important and very interesting topic which we are very familiar with in our day-to-day life. So you must be experienced in our day life that concept. As students here, this is Sandhya. I teach physics in Spark Academy. Spark Academy is extremely conducting YouTube live classes. You can join us for free live classes daily. So if you're joining the free daily live classes, and you can download the Spark Academy app. There are daily live classes in the app. There are daily live classes in the session, doubt clarifications, and free material in our app. Free material is provided. And the concept discussions will be with the tips and tricks for the all kinds of competitive exams like EAMCET, JEE, NEET. Admissions are open right now for this academic year 2022 to 23. Classroom as well as online coaching is available. Short-term crash course and regular batches they are conducting. YouTube scheduled classes about physics in a week is on Wednesday and Thursday. So we are having YouTube live classes on Wednesday and Thursday. So you can join us for live updates. So students, if you are buying any course from the Spark Academy, the branches are available at Narayanaguda, ECL, Mehdipatnam. So if you are buying any course, this is Sandhya. I teach the physics in Spark Academy. You can use the coupon code SAN10 for any course you are buying from the Spark Academy. So you can use this. You will get the benefit by using this code, and indirectly you are supporting me by using this code. Okay students, let us go to our topic discussion. So from the motion in a straight line, this is part 2. In previous session we have discussed non-uniform accelerated motion concept and related numericals. In this session, we are going to discuss from the motion in a straight line chapter, relative motion. Relative motion in one dimension, which is very important concept, and you will be having the numericals related to relative motion in 2 dimension also. So here the basics you need to understand and follow the model questions, then it will be clear to you to solve the numericals related to this concept. So to solve this relative motion in one dimension, let us discuss what is the familiarity in our daily life related to this concept. So you must be familiar with the experience of traveling in a train and being overtaken by the other train, or you are in a bus. it is being overtaken by the other bus, and they both are moving in the same direction. Now, the train that overtakes you, you are in one of that vehicle. Now, which vehicle is overtakes you? It must be traveling faster than your train. But as it overtakes, it must be traveling faster than your train. But it seems slower to you because you are in the one of the vehicle which is already moving. So now you are in the position which is moving. The vehicle is moving, you are in that vehicle, you are at rest. So it seems slower to you than it would be to someone standing on the ground and they are watching both the trains. So if both the trains have the same velocity with respect to the ground, then to you the other train would seem to be not moving at all. So you are in that one of the train. If they are maintaining the same speed, to you the other train would seem to be not moving at all. So to understand these observations, we introduce the concept of relative velocity. So relative motion in one dimension, in that mainly we are going to concentrate the numerical solving of relative velocity. Just like what is the familiarity and our experience while traveling. So how to solve all these observations? So we had to learn about the relative velocity. So students, let us go to the topic. Here, to describe the relative motion. Relative means with respect to other. Means, for example, if any object is at rest or it is in motion. To describe that state, we need one reference frame. So, in a relative motion, what we need? We need reference frame. So, this reference frame is nothing but from which all observations of motion are taken. That is the reference frame. All observations of motion are taken. Observations are nothing but, what are the observations of that motion? Means what is the time taken with respect to other, like that. Observations are nothing but distance traveled, what is velocity, what is acceleration, what is the time. So in relative motion, to describe the motion of the object, we need a reference frame which is in the space from which all observations of motion are taken. That is reference frame. So observations means indirectly we are measuring the distance traveled by comparing that velocities, and we can measure the acceleration and we can calculate the time taken in that situation. And one more thing we need to keep in mind, with respect to reference frame, RF means reference frame. Observer is always at rest. So we are taking observations of that motion with respect to reference frame. So that observer is always rest. So keep in mind these points we need to keep in mind. So to describe motion, we need a reference frame and where the observations are taken. And one more thing, with respect to the reference frame, observer is always at rest. And let us see. Now, let us consider two bodies which are moving in the same direction. Suppose if A and B are moving along the same direction. They are moving along same direction. Now, so how to write velocity of one object with respect to the other? Let us see here. Let us discuss. Here, reference frame is constant. So, with respect to which frame we are describing the motion of that object, that is at rest. Constant means it is at rest. In two ways we can discuss that relative velocity when the reference frame is constant, and with the moving reference frame also we can discuss the questions. So here the first case is reference frame is constant. So let us take example here. There are two objects A and B are moving along the same direction. Let A moving along the positive x direction and B is also moving in the same direction. Now, we are writing velocity of A with respect to B is equal to velocity of A with respect to B. We are writing it is the relative velocity. So, you are the person who is in the vehicle A which is moving with some speed, and if B, if it overtakes you, it appears to you slower than, it is moving in a slow motion than the person who is on the ground. But it is moving faster only if it overtakes. But here is the case, we are finding velocity of A with respect to B, which are moving in the same direction. As per the relative velocity, we can write VA minus VB. So difference in their velocities gives velocity of A with respect to B. Here, velocity of A is nothing but with respect to ground. Both are moving. Here reference frame is the ground. So reference frame is ground, which is at rest. So with respect to ground, A with respect to B is VA minus VB. And next case, if A and B are, if they are moving opposite direction, they are moving in opposite direction. Now A and B, two vehicles are moving in opposite directions. Let us take A is moving along positive x direction and B is moving along negative x direction. Now, both the vehicles' motion we are describing with respect to ground only. Now, relative velocity of A with respect to B is taken as VA minus of minus VB. Follow the sign convention. It is positive x-axis, it is negative x-axis. from the point of starting. One is in negative direction, one is in positive direction. So it is being equal to VA plus VB. So when the reference frame is constant, which is the ground, if they are in same direction, difference in their velocities is the relative velocity. If they are in opposite direction, sum of their velocities is the relative velocity. Okay, so let us discuss one example related to this where the reference frame is constant. See here, example, two trains. There are two trains having length 120 meters and 100 meters are running. They are running in the opposite direction. So let us see here. They both are running in opposite directions. With velocities, we are given with velocities 40 kilometers per hour and 50 kilometers per hour. So two trains are moving in opposite direction with their velocities. Now they are asking, in what time they will completely cross each other. Completely cross each other. This is the question. So here they are asking the time. Usually time is nothing but the distance traveled by velocity. Now the two trains are in moving, so their motion can be described with respect to the ground. So here we need to take relative velocity of the trains. So to calculate the time, at what time they can cross each other, means the distance traveled by relative velocity. Here the distance traveled is nothing but the total distance. So let us find first the relative velocity. We are taking here relative velocity of train 1 with respect to second will be equal to V1 minus direction. They are moving in opposite direction. Let the train 1 is in this direction. Train 2 is moving in opposite direction. So it is train 2. So can we write minus V2? Now V1 is 40, minus of minus becomes plus, so plus 50. Here it is being equal to 90 in kilometer per hour. But the time standard unit will be in seconds. So where it is in kilometer per hour, convert that value into meter per second. So we have to do 90 into 5 by 18. So 18 5s are. So relative velocity of the trains is being equal to 25 meter per second. Now, to cross each other, so velocity of the train with respect to we are finding, if it crosses the train 1, it needs to travel the total distance, which is the total length of the trains. So we can write time taken is equal to the total distance, which is 120 plus 100 by relative velocity, that is 25 meter per second. So here the total distance traveled is being equal to 220 by 25. I think we can cancel 25 is 0.8. Clearly, we are getting 8.8 seconds. Okay, here to calculate the time, your observation is what is the time taken to cross each other, and that too completely cross each other. When they cross completely, the total distance needs to be traveled by its relative velocity. Okay, now let us see. So this is about reference frame is at rest. Reference frame is constant, and related to this, let us go to few problems also. Next, we discuss the numericals about this when the reference frame is constant. Now, if the object motion is in a moving frame, now frame is not constant. Now, case 2 is, let us know about motion in a moving frame. We discussed the example question also. Yes. So, motion in a moving frame. Now, the reference frame with respect to which we are describing the motion of that object, that is also in motion. So, in that case, we can write body, a boy. Let us consider boy is in a train. Boy is in a train and he is running with velocity, with some velocity, and train is moving with some velocity. Let us consider train is also moving with velocity. Now, velocity of the boy with respect to ground, here boy is in the train and he is running with some velocity, and train is moving, and train is also moving with velocity. If we are describing the motion of the boy, means observations about the motion of the boy with respect to train. So here train is the reference frame to describe the motion of the boy, which is in motion. So it is a moving reference frame. Now we can write velocity of boy with respect to ground will be equal to relative velocity, means velocity of boy with respect to train, plus velocity of the train with respect to ground. Okay, so this is the velocity of boy with respect to the ground will be equal to relative velocity plus velocity of train with respect to ground. Now here we can discuss, like, if boy in a train is running along the direction of the train, take boy running along the direction of train. He is running along the direction of the train. Then how to calculate that velocity of the ball. It will be same. When both are in the same direction, velocity of ball will be equal to velocity of ball with respect to train plus velocity of the train. So from this we can write relative velocity. When both are in the same direction, relative velocity is being equal to velocity of ball minus velocity of the train. That is relative velocity. Now opposite direction. Let us consider opposite direction. Now the boy is running in opposite direction. In this case, velocity of boy with respect to, if you are writing VB, it is nothing but with respect to ground. With respect to ground will be equal to relative velocity minus velocity of the train. From this relative velocity, we can write it as velocity of boy plus velocity of the train. So opposite to the motion of the train, adding up their velocities along the direction of the train. Relative velocity, we are finding here relative velocity, not the boy velocity is adding up with the relative velocity. Train velocity plus boy velocity with respect to train. So this is about moving reference, relative motion in a moving train. Now let us see one example related to this. Let us take the example here. On the ground, on if there is one platform which is moving, which is provided with the wheels. This frame is moving with some velocity. Let us consider this frame is A. So velocity of this frame, which is A, equal to 5 meter per second. Now, there is a person, consider him a boy who is on this frame. Boy is B. His velocity, he is also in the same direction, which is equal to 3 meter per second. Now, velocity of boy with respect to ground will be equal to VB plus VA. This is that boy velocity. And this is frame velocity in which VB is given. So can we write velocity of boy with respect to ground is being equal to 3 plus 5, which is equal to 8 meter per second. So with respect to frame we are finding, and with respect to ground means we are adding up their velocities. So you can just follow this concept. When they are in same direction, velocity of boy with respect to ground, we are adding up relative velocity plus velocity of the train. Instead of train, we are taking one frame which is moving. Yes, because and always consider a reference frame. With respect to reference frame, observer is always at rest. So here with respect to train means we are taking here only that velocity of boy with respect to train. So this is an example of a moving frame. For example, for example, there is a frame which is moving with some velocity, and the person on the frame, he is moving perpendicular to the direction of the frame. Frame is moving in this direction. The person who is on the frame, on this form plate, it is like a plate. On this platform, the boy is running perpendicular to the direction of the plate. So here we can write velocity of boy with respect to ground means here we take velocity of boy plus velocity of this frame. Same, we follow the same. But their directions, they are not in same direction here. Did you observe? It is the boy direction. Boy direction is in this way and frame direction is horizontal. So having angle between them. Now this will be the relative velocity. These two resultant vector will be the relative velocity. These type of questions can be asked in relative motion in 2 dimensions. So today mainly we are following velocity in 1 dimension, relative velocity in 1 dimension. So let us go to few questions related to this concept. So students, if you are buying any course from the Spark Academy, and why you need to choose the Spark Academy means, it is our methodology. It's very important. So in classroom coaching, in the Spark Academy, we follow means we teach in the classes right from the basic concepts. Shortcut methods will be discussed. All model questions related to the concepts and exercise questions will be solved. Previous year's questions will be discussed regarding that concept. Chapter-wise tests will be conducted, weekend tests will be conducted, grand tests will be conducted, and test analysis will be given after the test, which is very, very helpful for your preparation of any competitive exam. So, due to this very effective teaching methodology, you can choose the Spark Academy, which is very beneficial to the student whoever appearing for any competitive exam, EAMCET, JEE, and NEET. So students, you can come and contact the institute. The branches are at Narayanaguda, Mehdipatnam, and ECL. So if you want any information, you can contact any of these numbers which are given below for the admissions. Yes. Let us discuss the questions. That velocity in 1 dimension. The first question here we are given with, suppose 2 cars A and B are moving with uniform velocities with respect to the ground along parallel tracks and in the same direction. So now both the trains are in the same direction. So with respect to ground means individual velocities. Means both are on the ground. We are comparing their motion describing their motion with respect to ground. Here reference frame is constant. Let the velocities of A and B 35 km per hour due east, 40 km per hour due east respectively. Both are in the same direction. Here it is 35 km per hour and B is also. It is also same direction but 40 km per hour. They are asking what is the relative velocity of car B with respect to A. When they are in the same direction, we are finding velocity of B with respect to A. So we can write VB minus VA. This is nothing but VB with respect to ground minus VA with respect to the ground. And VBA is the relative velocity. Yes. So we can write VB is 40 minus 30, which is equal to 10 km per hour due east. So one of the vehicle velocity, one of the car velocity is greater than the other. So with how much speed it is moving? Sorry, it is 35. So difference will be equal to 5. For example, they are asking velocity of car A with respect to B. Actually, here is the possibility B can overtake the A as it is having the more speed, maintaining the moving fast. So it is possible case 5 km per hour with this speed it can overtake. So what is the relative velocity of car A with respect to B means? Here we need to consider VA minus VB. So if it overtakes this car B, as per this 35 minus 40, this much lack of speed car A is moving. But here they are asking car B with respect to A. When both are in same direction, VB minus VA we have to take. Now, question number 2. Two trains A and B are moving with uniform velocities along parallel tracks but in opposite directions. One is positive direction and the other one is ahead to the first one. Let the velocity of the train A be 40 km per hour due east and that of train B, it is also 40 km per hour due west. So it is east direction, it is west direction. Now they are asking calculate the relative velocities of the trains. Means velocity of train A with respect to B, velocity of train B with respect to A. Let us see here, it will be VA minus VB. Actually, both the trains motion we are describing with respect to ground. So a reference frame is ground, which is at rest. So the observer is on the ground. He is observing both the cars. Sorry, here trains. So with respect to reference frame, observer is always at rest. So when they are in same direction, we get difference in their velocities. But in this question, two trains are in opposite tracks. So we get sum of their velocities. And VB, velocity of B with respect to A means, we can take it as minus VB minus VA. We get it as minus of VB plus VA. means their relative velocity is having same magnitude only, but in opposite direction. So A with respect to B will be equal to 40 plus 40, which is equal to plus 80 kilometer per hour per hour. It is due east. We are getting positive. Positive direction is east direction. And velocity of B with respect to A is being negative of VB plus VA. Means we can write minus 80 kilometer per hour due west, because B is in west direction, which is negative direction. It is positive x direction, it is negative x direction. So you can say due west. So they are asking calculate the relative velocities, means this way we have to find. Next, let us see one more question. Consider two trains A and B moving along parallel tracks with the same velocity in the same direction. Let the velocity of each train be 50 km per hour due east. Now both the trains are moving in the same direction. Both the trains having the same velocity, 50 km per hour due east only. Calculate the relative velocities of the trains. So in this case, let us consider first train is A, second train B. In this case, when both are in same direction, velocity of A with respect to B will be difference in their velocity. Then, both having the same speed. So with respect to ground, the observer who is on the ground, who is at rest, it appears 0. They are not moving. Or a person either of the trains, who is in that either of the trains, if both are maintaining the same speed, it appears it is not at all moving. So VAB will be equal to 0 if we are taking VBA, velocity of B with respect to A. Even in this case also it is 0. So similarly, both VAB 0, VBA is also 0. Because they are in same direction, relative velocity is being equal to some difference in their velocities. If they are in opposite direction, relative velocity will be equal to sum of their velocities. Let us see one more question here. How long will a boy sitting near the window of a train traveling at 36 km per hour see a train passing by in the opposite direction with a speed of 18 km per hour? The length of the slow moving train is 90 meters. So, starting what we have discussed, our familiar example. So, when we are in one vehicle which is moving and the other vehicle which overtakes us, it must be traveling faster than your train, but it seems slower to you. So, it appears to us very slow, which is in slow motion. But it seems slower to you than it would be to someone standing on the ground and watching both the trains. Now let us see here. Passing by it in opposite direction with a speed of. So velocity of, let us consider relative velocity. Treat that velocity of train 1 with respect to 2, which are in opposite directions. Opposite directions means we get 36 plus 18. That is the relative velocity. So when they are in opposite direction, relative velocity will be equal to sum of their velocities. So it is being equal to 54 kilometer per hour. Now, the length of the slow moving train is, so the train 2 which is passing in opposite direction, it appears to that boy in slow motion. So its train is 90 meters. So now that boy who is sitting near the window of the first train will watch the total length of the train when it passes over the first. So he will watch the total length, then the time will be equal to that length of the slow moving train by relative velocity. So we can write like 90 by 54. So 90 by 54 value, so just to calculate this value. So here we are getting like 1.6 seconds. So when they are in opposite direction, we got the relative velocity is the sum of their velocities. Then the time taken, why we are calculating time is how long will a boy, means how much time taken to pass the first train where the boy is sitting near the window. So that time we calculated. Now let us see here. Now it is about a swimmer. Yes, a swimmer's speed in the direction of a flow of river. So let us take, this is the river flow. In this direction, if there is a river flow, and the swimmer is swimming in the river. So here, swimmer's speed in the direction of the river flow means, in the direction of the river flow means Vs plus Vr. Along the direction of the river flow, we need to take it as 12 kilometer per hour. And against the direction of the flow of river, the swimmer's speed is 6 kilometer per hour. Means it is opposite, means like Vs minus Vr. It is 6 kilometer per hour. So whenever swimmer is swimming in the flow of river, along the direction of the river flow means we need to take sum of their velocities. But this is not the individual velocity of swimmer or a river. It is like a relative velocity. So it is like a the swimmer is in the river in same direction, their relative velocities are given. In opposite direction, its relative velocity is given. Now, calculate the swimmer's speed in still water and the velocity of the river flow. So we need to find what is the velocity of the swimmer and what is the velocity of the river. So let us calculate here. Velocity of just these two equations you can, by following algebraic rules, you can just add or subtract. So here we are adding. So we get 2 plus Vr minus Vr cancels. 2 Vs will be equal to 18. then Vs will be equal to 9, because 18 by 2, it gives you 9 meter per, it is kilometer per hour. And we need velocity of the river also. Substitute Vs in the above any of the equation. So we are substituting in the first equation 9 plus Vr is equal to 12, which gives Vr is equal to 12 minus 9. 12 minus 9 means 3. So 3 kilometer per hour. So here we need to remember the swimmer is in the moving frame. With respect to river, if we are describing the motion, it is a moving reference frame. Along the direction means we are taking their individual velocity system, and opposite to the direction means we are taking their individual velocities difference. And we are finding individual means velocity of the swimmer means it is with respect to ground. Velocity of the river means with respect to ground. Here, their relative velocities are given in the question. Now, let us go to the next question. When two objects move uniformly towards each other, they get 4 meters closer each second, and when they move uniformly in the same direction, with original speed, they get 4 meters closer each 5 seconds. Okay, find their individual speeds. So first, two objects moving uniformly towards each other means they are in opposite direction. They are getting 4 meters closer each second. So in a first case, they are moving uniformly towards each other. Two objects, let us take V1 plus V2. Because in opposite direction, relative velocity will be sum of their velocity. Is being equal to how much closer in each second? So that distance by, it will be, that relative velocity will be equal to distance by time. Time taken is 1 second. So it is being equal to 4 meter per second. And when they move uniformly in the same direction, so in second case, now they are in the same direction uniformly. So it will be same direction means V1 minus V2. So how much closer each 5 seconds? 4 meters, time taken is 5 seconds. Like velocity is equal to, that is nothing but relative velocity is equal to distance by time. So in the opposite direction, relative velocity is V1 plus V2. In same direction, relative velocity is V1 minus V2. So 4 by 5 means which is equal to 0.8 meter per second. It is same as like the swimmer in the river flow. But swimmer is in the moving reference frame. We just got, you can compare these two questions. Swimmer is in the moving reference in the river which is moving. When they are in same direction, positive, we consider relative velocity. When they are in opposite direction, we consider difference. Here, when they move uniformly towards each other, we are getting sum. When they move in the same direction, we are getting difference. Because here reference frame is ground, which is at rest. Reference frame is not moving. We are comparing both the velocities with respect to ground. That is the difference of when reference frame is constant and when frame is moving. Just opposite cases we get. Yes. Now they're asking, find their individual speech. In this case, we have to find what is V1, same as the simplification is same as the previous question. So like here only I'm adding, just add, while adding we get plus minus term gets cancelled. 2V1 is being equal to 4.8. From this we get V1 is equal to 4.8 by 2, which gives 2.4. Substitute the 2.4 in the above equations, any of the equation. So we are substituting in the first equation. We get 2.4 will be, 2.4 plus V2 is equal to 4. Then we get V2 is equal to 4 minus 2.4. 4 minus 2.4 is being equal to 1.6 meter per second. Yes. And one more question, it is related to moving reference frame. See here, a person walks up a stationary escalation in time t1 second. If he remains stationary on the escalator, then it can take him up in t2 second. If the length of the escalator is L, then determine the speed of the man with respect to the escalator. Determine the speed of the escalator. How much time would it take him to walk up the moving escalator? So first A, speed of the man with respect to escalator. Actually, he is on the escalator which is at rest. Now the escalator with respect to observer who is at rest, it is taken him up. Sorry, he is walking, escalator is at rest. So we can write it as he needs to travel the distance which is length of the escalator, and he is walking up in a time t1. That is the speed of man with respect to the escalator. Because they given length of the, he needs to walk up this much length, so distance travel will be L by t1. Next, determine the speed of the escalator. Speed of the escalator when the escalator is escalator take him up in t2 seconds, person remains stationary. So now we can write speed of the escalator will be equal to, so the distance traveled, it takes him up by traveling length of escalator in t2 seconds. And third, how much time would it take him to walk up the moving escalator? So it is, now velocity of man will be equal to, see, they are in same direction now. Here, velocity of man with respect to ground. Here reference man is on the moving frame. Here frame is moving. So we can write velocity of man with respect to escalator plus velocity of the escalator when they are in same direction. Then the relative velocity will be difference. It is same as what we have discussed at the moving reference frame. You can observe here this one. So when the frame is moving, motion in a moving frame in the same direction, if they are in the same direction, relative velocity is difference. When they are in opposite direction, relative velocity is like this. But comparing with the ground, what we are getting here, same, we are following this concept. So here, velocity of that man with respect to ground will be relative velocity plus velocity of the escalator. So let us substitute above values only. So L into 1 by T1 plus 1 by T2, which will be equal to T1 T2 by T1 plus T2. Because we need to find the total time, which is equal to length by velocity of the man. So take L by Vm, this will go that side, then the time taken him to walk up the moving escalator. So students should follow the concept clearly and can try the more questions. And here we are giving you few questions to solve yourself and post your answers in comments. And this is one more question. Thank you. Have a nice day.